when you think of a computer, what do you think of? Like, what comes to mind? Okay, we're pointing to the computers that are on the back of our screens, okay?
Gaming device.
What else?
One of those old things.
One of those old an old Mac?
I think of it as any personal device.
Any personal device, so it could incorporate phones or mobile device because they're all computing. So what we view as a computer has definitely changed, especially over the last, I'd say 5 to 6 years. Actually, really in your guys' lifetimes too, because we've become a mobile-first society in that you see less and less people having PCs or laptops, unless they are like you guys. A lot of you have your gaming rigs and whatnot. But a lot of the interacting that we do is based on mobile devices. But behind those mobile devices are a bunch of servers, a bunch of services that help empower those. So that's what we are going to be going through this course. We're going to try to touch every aspect of computing, because when you get a job, you don't know if you're going to be supporting 100 Windows machines or 100 Linux machines. You don't know what that looks like. Or even if it's some like Great Clips, for example, the haircutting place, their POS system has been an iPad for the last, I want to say like 3 years, and that's nationwide. So you're going to have to support, the iOS device. You're going to have to know, how the different dongles work, how, what's the difference between USB-C versus, Thunderbolt, all those different things. You're going to have to go in knowing that, because once people find out that you know a little bit about technology, and this has probably already happened to you, they are always going to come to you with every single issue they have, whether you're qualified for it or not. So my life as an IT director, one day I might be working on, getting some new, updates or patches on the server. The next day I'm in a teacher's classroom trying to diagnose why her cassette player didn't work. Yes, I said cassette. Okay. So as a technologist, you're going to have to, my goal is just to have you guys understand how things should work, and then you can apply, you'll kind of develop your own troubleshooting methodology in order to be able to troubleshoot absolutely anything. So if somebody walked in right now and they were like, hey, TJ, I have this problem with this, what is something that I've never even messed with before? We're having an issue with our generator. It's not, when we send the commands from the computer, it's not starting up, okay? I know nothing about generators, per se, okay? But I have an idea, or I can look at how things are supposed to work, and using my knowledge of technology, I would probably be able to overcome that issue, okay? Just because I've been around the technology for so long that I've developed my own troubleshooting methodology, so that's my goal for you guys as well. So, like I said, this is a really, really big module. So we're gonna jump into it so we can make it out of here on time. So starting off with our personal computer, okay? What's really important is that we realize that even the smallest amount of electricity can fry our computers, okay? And then not only that, we are working with, computers that have power supplies that could discharge and cause electrical shock harm to you as well, okay? So there are a few things that you can do to kind of prevent that from happening, and that's what we're going to go through here. First and foremost, a lot of times we will try, let's say we can't find an adapter or a power cable for something, we'll try to pull it from something else just to see if it'll work. Well, when you're doing that, it does cause harm to electronic devices, because it might send more voltage or less voltage to the components, and it could cause issues, okay? So some of these things might seem like common sense, but there's a reason that they have to be on the slides. And also, this is a question that you would see on the A+ exam. They might ask you something like, you can't find the AC adapter for a laptop, what should you do? Use it from a different model laptop to see if it works, order a new one, and there will be like 2 other answers that are kind of similar. So when you see questions like this or things that are common sense, that's good, because that means you're just that much more prepared for the A+ exam. Also, when it comes to high voltage, a couple things that you want to look out for, like what devices have kind of the most voltage. CRT monitors from back in the day, they might be fun to pick up and throw and smash, but they have they held on to a ton of energy. There was people that did die from messing with CRTs, which I'm glad they're gone. But you will run into them, I promise, at some point in your career. Does anybody not know what a CRT is when I say a CRT? It's okay. Do you know what a CRT is? So a CRT is like the old school, big, chunky monitors. We have one next door attached to the Apple II, if you want to see what that's like. And that was my first, like when I built my first gaming PC, I had a CRT monitor. And I remember going on a family vacation to Florida with that in the back. And like we got into the hotel and I like hooked it all up. And my parents were like, we're at Disney World and you're setting up a PC. I said, hell yeah. Hell yeah. So another thing that holds on to a lot of voltage is going to be your printer parts, okay? So especially like laser printers, they have to get really, really hot in order to do what they do. So don't go unscrewing stuff or taking printers apart unless you go into a field where they do that training. We have a lot of good vendors in the area that do work on copiers and printers, so it could be a good entry-level job for you, but make sure that they are doing proper training on how to take those things apart. Don't just grab your screwdriver and go at it. It's just not a good idea. Anybody know what ESD stands for?
It's on the board.
Yes.
Electrostatic discharge.
Yes, it is electrostatic discharge, okay? So I want to point out something. So if you've ever walked on carpet and then touched something, you'll feel that kind of shock. So in order for you to feel that shock, that is 3,000 volts of static electricity must build up before you can feel it, okay? So by the time that you reach into a computer to do something and you feel that shock, that means that voltage is already arced and it is already frying components, okay? And that's just for you to feel it, okay? So that being said, it could be, say, 2,500 volts, and you might not feel it, but you're still, when you touch those electronic devices, you could be causing them harm. So that's why I recommend kind of doing the discharge. In Geek Squad, we always had electrostatic mats, but we also would make sure that we touch something metal before we worked inside the PCs. A+ wants you to, and it is good practice to wear the straps, but in reality, in practice in IT, you are going to be hard pressed to find them. At least I haven't in my career, and I've been in a lot of different environments, and you just don't see the straps very often. But when you guys take apart your PCs, we should have enough straps for everybody just so you can kind of understand how it works. But note, the A+ wants you to wear them, and if you are setting for the A+, I would definitely screenshot this, because this is a prime thing that they would pull and put on the exam itself. So after this, we're going to go through the lecture first, but then you'll have a lab that talks about different types of safety. So it's personal safety, electrical safety, fire safety, and stuff like that. Okay, so that's the safety part of it. Any questions over any of that? No? Cool. So PC components. So when we look at the different shapes inside, anybody here been to Micro Center? A couple people. So if you've never been to Micro Center, you go to the case aisle. And there are cases of every shape and size. So you're going to have vertical cases, like a regular standard PC, like this one right over here. You'll have horizontal cases, which look like almost like home theater machines. You can have rack mountable, like for servers and stuff like that. So PCs come in different shapes and sizes, and that's usually based on either an aesthetic that someone wants or for a specific purpose. Okay, so you might be building a computer, like a home entertainment type of thing, where you want a media center for your living room. Well, the vertical tower doesn't really look as nice in your living room, so you might get a specific, nice looking home theater case that's more of a horizontal, the horizontal build, if you will. Or you might not want anything showing, and you might look at maybe an all-in-one. We have an iMac at our house. We love our iMacs. And it's just easy because there's not a bunch of cables and stuff like that. So it really depends on your use case and what the computer is going to be used for, or like if you're looking for a specific aesthetic. There we go, an aesthetic. We used to build PCs, but we got away from that when it kind of changed to cybersecurity. But if you are wanting to build your own PC, please get with me, and I can help you kind of navigate that as far as the different parts to put in it, as well as there's different websites out there, and I put them in the actual unit itself to make sure all your parts will work together. So when it comes to power supplies, it's important to know these different types of power supplies, and there are others besides this, but these are the main ones. So the first one is AT. That's going to be your old school. You still see them in some like manufacturer builds, but not. You don't really see them anymore. You see more of the ATX, the 12 volt. That's what you see, like where you have the modular cables, the kind of thinner cables. You don't have some of the old dated things on there, like the floppy cables, or you still see some of the 12 volt Molex cables, but they are a lot more streamlined for what is needed today. Like so on your AT and your ATX, you probably wouldn't see your video card power cables, because that's something that's within the last couple of years where we needed more dedicated power for those video cards. So what you have today is an ATX 12 volt. Those are the power supplies, like if you helped build any of the PCs here last week, that's what you were dealing with. And then you'll also see what's called the EPS 12 volt. Sometimes you'll see that for your PC builds, but a lot of times those are for use in network equipment or servers. So these are the different cables that you have. When we do our review for the exam, one of the things that I'm going to ask you to put into your Kahoot is a photo of these and a matching. Has everybody here done Kahoot before? Do your other teachers use Kahoot? No? Some yes, some no? Okay, good.
Played it, but I haven't made it.
Okay, played it but haven't made it. Okay. So I like it because you guys kind of put your own. It's interesting to me to see like what you guys thought was important from the lesson, and then I can kind of help steer with what actually we want to cover. And with everybody, well, you guys do them in groups or pairs. I mean, so in here we'll have like 10 different Kahoots that we'll take a day and kind of go through. We'll cover a lot of the information. But one of the things I would say is easy 5 questions is to have a picture of the connector and have it be one of the answers be what it is. Different power supply voltage. The most common voltage that you're going to see is 3.3, 5 volts as well as 12 volts. The smaller, your smaller voltages tend to be for smaller components or smaller chips, whereas your 12 volt is going to be more for anything that has like a standard disk drive, like the old school regular hard drives, the non-solid state ones, your fans, a lot of your like fan controllers, they'll sometimes have your 12 volt supply as well. So smaller voltage is going to be more for like LEDs or smaller components. But if you have to move something, that's going to be your higher voltage with your 12 volt. Power supplies can be what's called a single rail, dual rail, or multi-rail. And that's just basically the amount of, I guess I always look at it as like the smarts that are inside, in that it separates them out into different PCB components, basically like little circuit boards to help control how the energy actually flows. So with dual rail, or multi-rail, you're splitting up the amount of computing, but you're also you're kind of dividing and conquering. So if one part fails, then the whole thing doesn't necessarily fail. You could have some redundancy as well. You're going to see some wonkiness. You're not going to be able to probably fix it, but it does help it run more efficiently. Does anybody know what the difference between a blackout and a brownout is?
Brownout is, there is still some power in the grid, but it jumps around and it's very unstable.
Okay. And what about a blackout?
No power.
What's that?
No power at all.
No power at all. So it's cut. There's nothing there. What do you think is worse for electronic components? Brownout. Absolutely. So with the brownout, you have this weird sag, and then these peaks. So it's constantly going like this. And things like power supplies don't know how to regulate it. You know, they like clean power. They like to see those levels exactly where, you know, that they can depend on, so that way they can make decisions on it. So that's where things like UPSs, okay, UPSs, which is a backup battery source, those are great, but in the server environment, they're even better because it's also conditioning the power that's going in, and it's giving it that constant nice wave that it wants to see in order to power the components. So it doesn't, you don't see those huge, you know, sags that sit there for a minute and then come up and spike. It gives it exactly the voltage that it needs, and it keeps it nice and clean. Any questions on power supplies? Pretty straightforward. Plug them in. And you guys understand the difference between a modular power supply and non-modular? Okay, from kind of working with them all last week, we had different types back here. Cool. Motherboard is the backbone of the computer. This is what everything plugs into. So the motherboard consists of your north bridge and your south bridge, and then your different interfaces for different things. So you'll have like your different ports, your different sockets, your different pins and stuff that you can connect things to. This is where everything gets plugged into. So this is arguably one of the most important parts on the device itself. It's doing a lot, okay? So what's a telltale sign that you have a bad motherboard? What is one thing to look for when we're doing our physical inspection of it? Yeah.
I was going to say no post.
No post, okay, but even just, hey, this isn't starting up, it's not posting, and you look at the motherboard, what is something that would be a telltale sign? Yeah?
Pins in the CPU socket.
And pins in the CPU socket, absolutely. Anything else? Yeah?
Moisture damage.
You can see moisture, maybe, yeah.
You can see like corrosion.
Corrosion, sure. Has anybody ever heard of blown capacitors?
Mm-hmm.
Okay, so let me grab one of the motherboards back here, but that's something that when a computer would come into Geek Squad, that was always the first thing that we would look for is blown capacitors. Okay, so a couple of motherboards I'm going to pass around for you guys. See if we can find some blown capacitors. And watch them are kind of sharp on the bottom where the actual pins came through. And pass those around. So you can see at the top, or in this case, on the side, we have our CPU socket. This is where we plug in our CPU, whether that be AMD or Intel. We have our slots for our RAM. It's important when you look at the motherboard or look at the manual to know what slots you're supposed to put the RAM in if you're not going to be filling all of them up. We have our different expansion slots here. So these are our PCI Express and PCI expansion slots here at the bottom. Chipset, you don't really see the chipset. It's not like something that you insert. It's actually part of the board itself. But in this case, it does have a cooler on it. We have the actual BIOS chip, which is this little guy right down here. And it'll also have the UEFI. So back in the day, we had our BIOS, which was our basic input-output system. That was the operating system that really just ran on the board. And then after everything went well, it would hand it off to Windows or Linux or whatever operating system that we installed on the machine. You would then kind of hand it off to that. And back in the day, like you could only use your arrow buttons, and it was very much like a blue and white, basic, very basic operating system. Nowadays, we have what's called UEFI. And now we have mouse control, it's graphically pleasing. We're seeing actual like live readouts of the processor clock speed. The BIOS that you guys call it now, or the UEFI now, is so much better than what we had before. It really was just basic. Like you could change the boot order and you could change the time. Other than that, you weren't really doing much. You weren't changing clock speeds. You weren't changing. You didn't have different profiles for different things like you have now. It was very much just a basic input-output system. Now it's like a small operating system that's running on the board itself. So you can see here too, we have our SATA connectors. So that's going to be right here. You can see them on the boards that you have as well. And then you might also have an internal USB connector. You see that a lot on servers where you'll actually have a USB port that's on the motherboard itself that you can put a flash drive in. Sometimes you run your virtualization software like ESXi or Proxmox. You would run that on the actual flash drive in there, and then you would have your regular drives, or you might need that for any diagnostic purposes. There's a couple different reasons that you would use it. But then you have your USB headers as well, and that's where if you have an expansion card or you want to plug in your front ports, that's where it would be. So let's talk a little bit about the chipset itself, okay? Who can give me a good example for my PC nerds in here, my PC geeks? What is a chipset? If you're explaining a chipset to your grandmother, how would you do that?
I don't think that's possible.
You don't think it's possible? Oh, it's absolutely possible.
I think you should move my grandma.
So your chipset is all of your integrated components. So this is going to be like your audio, your LAN, if you have onboard video, that's all going to be tied to the chipset itself. So if you see ports that are on the back of the board itself, those are all going to go back to our chipset. Now our chipset has two very distinct, processors, if you will, or sections that process data. We have our north bridge and our south bridge, okay? Our north bridge is very, very fast, okay? It can get information back and forth very quickly because it's the closest to our CPU, okay? So on this, we are gonna have our PCI Express, which is our graphics card. We have our RAM, which is our temporary, where we put like our temporary computations, and then we have our CPU. Because at the end of the day, our job is, we're doing input, it's hanging out in the RAM, it's going to be processed in the CPU, and then it's going out to the output, whether that is our monitor or whether that's our hard drives. Because you can see, they are connected. The north bridge and south bridge, they don't operate alone, they are in fact connected. So over here on our south bridge, this is where things are a little bit slower. So we have our hard drives, because again, we don't want to have our bottleneck. Our job is to compute things as fast as possible. If we came in here and threw a hard drive in here, especially if it was like a slow hard drive, and we put that in the mix, it would slow everything down. So that's why we do keep them separate. Because after this computing is done, then it hands it off to the south bridge and says, hey, this is going to the hard drive, you deal with it. Okay, I'm going to keep computing things very quickly. Same thing with our PCI Express, our graphics slot, is it's constantly making all those calculations, right? For our video, for different video games or for rendering, it's crunching a lot of small numbers very quickly. So again, we need this back and forth as soon as possible. A couple other slower things on our south bridge, that's gonna be our BIOS or our UEFI. We're also gonna have our keyboard and then our slower expansion slots. So you can see here we have our video slot, but then we have some other expansion slots. That's going to be for things like our audio cards, or maybe we have a capture card. We might have like a USB 3 or USB-C expansion card. Those don't need to go as fast as our graphics card, so those are going to be on our south bridge. So does that make sense? Does anybody have questions about the difference between them?
Way better than test out.
Way better than test out. All right.
No idea.
I mean, you got a diagram in words, so
I'm already doing better, right? Okay, so there are a couple different form factors, okay? So you have ATX, which is kind of our largest, going all the way down to our ITX and our mini ITXs. You can see the different sizes of boards by the ones that are passed out. I'll actually bust out another one too. This one's really old school. These are the motherboards that we use. Look at that bad boy. That's a chunky boy. Yeah.
What the side mounted CPU?
Pentium 2 in that bad boy. The fan has been removed, so they didn't steal the fan, unfortunately. But yeah, so this would be your more of a full-size motherboard compared to the mini ITX. And the ITX, like right behind him, there's one of the mini ones as well. I want to say that one might be mini ITX. Because it's super, super tiny. So again, this is based on what you're going to do with the machine. Now, why? I guess let's talk about some use cases. Why would somebody want to use a ATX size motherboard? Yeah.
More RAM slots.
More RAM slots. Okay. What else?
What's another reason? Yep. You usually don't get as hot.
Don't get as hot because the components are maybe spread out a little more.
Yep. More SATA connectors on it.
More SATA connectors. Okay. Anything else? Yeah.
Usually a better I/O.
Better I/O. Okay. So, why would someone want to use because that stuff all sounds amazing. So why would someone want to use a micro ATX or a mini or ITX size?
It's like building a tiny computer.
Space, building a tiny computer.
Form factor.
Form factor. Yep.
More portability.
More portability. That's why when I built my PCs back when I was a lot more into the gaming space, I always went with micro ATX because I would build small PCs that had like handles on them that I could take them with me because I grew up on dial-up, so we literally had to have LAN parties and like connect each other in order to play Counter-Strike Source. So again, I wanted that nice portability that I can just grab and go. Nowadays, building obviously full size because I really, really want the I/O. I want to have 12 USB 3 and 4 USB-C and just the ability to add on more if I want it, instead of being just limited by just one or two ports. Same thing with RAM. So those are, and I don't think you really have to know the sizes, like the specific per inch, but it's important that you can, if given a picture of all of them, be able to match them with the size that they are. Okay, does that make sense? Cool. What is a CPU? Okay, so now let's try this again. Maybe Chipset was a little bit difficult to explain to your grandma, but can someone explain a CPU like you're explaining to your grandma? Yes.
It's the brain.
It is the brain, okay? Let's expound on that a little bit more.
It does all the calculations with the computer and organizes its entire function.
Absolutely. So it's going to do a lot of the computations because, again, at the end of the day, the PC is only working with ones and zeros, okay? And they're being calculated by the processor itself, or the CPU. So that is the brain of our entire organization, if you will. If our computer was a company, the CPU would be the head honcho. He would be the CEO. He's the one that is making all the decisions. He is going through and doing all the computations. So the actual socket itself is what exists on it's really two parts because you have a male and female side, but it's what exists on the actual board itself. So this is the actual connection between the CPU and the board itself, okay? So there's two different types. There is the PGA, or the pin grid array, which is where the pins are on the processor, and then there's the LGA, which is where the pins are on the socket instead of the processor. I think I passed out examples of each. Or all these.
That one's over there. There is no pins left.
Yeah.
They're all sideways.
Definitely bent pins on that one. So you can see here all the different bent pins from inside the CPU socket. And then you can see this here where it has just the holes for a PGA, where the pins would actually go inside the pins would actually be on the CPU. Any questions on that? Definitely an A+ question that they would pull from. They would have a picture of either one of those and say identify it, or tell us the difference between the two. Okay, that's something that would definitely be on there. Okay, let's talk about how to keep these things cool. What is the number one enemy of any computing device? Heat. Number two would probably be the user itself, but yes, definitely heat is the number one enemy. Okay. Now we have these really cool things that are kind of sealed all-in-one water cooling units, which are super easy to install, as we saw last week if you helped with the build. But you could have just a pin or just a fan where the pins plug into, or the socket just plugs into pins on the motherboard. You can have heat sinks, which will just dissipate, kind of radiate the heat out. The difference between the two are whenever something's moving, that's going to be your active cooling. When there isn't anything moving, that's going to be your passive cooling. So we see our heat sink over here versus our actual fan, okay? You can take a deep dive into kind of the best ways to cool PCs. I mean, you have to make sure the fans are, you know, the right direction in order to pull heat out and also push heat in. For me, I always went with the liquid cooled solutions just because, and now even more, they're just very easy for the price. Even back in the day, like we actually had to like fill up our reservoirs and do all that crazy stuff when they first came out. A friend of mine actually did phase change cooling in one of his PCs. So he actually, are you familiar with what phase change is?
Yeah, it changes, it like boils the liquid itself.
Yeah, so it'll go from a liquid to a gas. Think of it like, he actually took apart a old, I want to say like an old refrigerator in order to do his, where it had the Freon moving through it in order to keep it cool. I think he might have ended up in a magazine because of that. But yeah, there's a lot of crazy stuff that you can do when it comes to cooling. One of the things I want to do with you guys by the end of the year, hopefully we can get everything like ordered and whatnot. But I've always wanted to do a fish tank PC where the components are just in the oil. I just feel like that would be a really good display piece. So I have the aquarium already, I just have to order the different components, which is why I wanted to get some of these to find out kind of what PCs were working. So in case we couldn't order new parts, we had some of these older ones to use. But yeah, I think that'd be a really cool thing. And then we could 3D print some like cool stuff for our aquarium. Anyway, I digress, not digest. All right, types of memory. Okay, so what do you need to know about memory? The number one thing that you need to know is the difference between ROM and RAM. Okay, ROM is going to be actually on the, it's going to be read-only, so you can only take information from it. Whereas RAM, it's going to be kind of a temporary working space, so I can put stuff on it and I can take it off. Okay. So when it comes to ROM, ROM tends to have, like, they have ROM like programmers, for example. So an example would probably be like a game cartridge. So like a Switch game, for example. That's still using cartridges. That would be more like your ROM, in that it's read-only. And then you have your saved game, which is saved on your Switch itself, and it tells that ROM kind of where to pick up where it left off. We also have ROMs on our devices themselves, so that's going to be your ROM chip. So the big thing to know between the two of them as well is RAM is going to be volatile, which means when we lose power, we're going to lose the data that's on it. Okay, so if there was anything that was on your RAM itself, chances are you would lose that if it does power down. Okay, let me try to pick up where I left off. All memory, that's a really important point. So all memory chips store data in the form of bytes. A byte is a block of 8 bits, okay? So our bits are either going to be R0 or R1. And like I said, computers only understand those bits, right? Those zeros and ones. And then as it comes through, it's going to put it in a block, and that's going to be our byte itself. So 8 bits are in a byte. That's something that you absolutely have to write down. Remember that. Have that ingrained in your head. So tell me then, everybody wants to put more RAM in their computer. Why does it make it go faster? Why does more sheep in a computer make it go faster? Anybody? Mm-hmm.
You're able to process more information at a time.
Right, you're able to keep your CPU can move at, you know, that Mach speed. So the more that we can have things ready, so I like to think of it like a tree chipper, okay? I just have this tree chipper just sitting there spinning, and then I throw a stick into it and mulch comes out the other way, okay? The more that I toss in, the more mulch we can create. It's the same thing here. So the more RAM, that's just more storage that I have that I can actually throw in to be computed, okay? So that's why more RAM is beneficial. Nowadays, I feel like 64 is probably the max that most people go or are comfortable with, or even 32 is plenty. I run 128 in my builds only because I do a lot of virtualization. So I have multiple computers that are utilizing dedicated, actually dedicated where I want to do a server, 8 gigs or more. So I tend to build mine at the higher amounts, but it all depends. It's all based on the actual use case itself. Any question on RAM? Can you download more RAM?
Yes. It tells you how to create text.
Download more RAM. What is it? .com. I think the website.
Sounds about right.
So, like we were talking about earlier, the different types of ROM are your ROM chips, your PROM, your EPROM, and your EEPROM. So, again, these are all based on different use cases. You're not necessarily going to have to know what each of these do, but just be able to, again, identify that they are read-only, which means we're only going to pull information from them, okay? Different types of RAM going back. You probably only need to go back to like DDR3 and 4. For this test, probably just know for A+, just knowing DDR4 and DDR5 speeds would be very beneficial. And then also knowing the difference between our DIMM and our SODIMMs. Okay, so this is what we're going to talk about here. So the most common things that you're going to see when working on PCs are going to be your DIMM modules, which is your dual inline memory modules, or your SODIMM. So these are kind of our smaller form function DIMMs, which are on small PCs. So these have SODIMMs in them because they are a smaller build. So they're actually running laptop RAM in them, whereas your full-size computer is going to run full-size RAM, just your DIMMs, okay? So making sure that you know that SODIMM equals laptop would be very beneficial for your A+ exam and being able to identify the differences between them. Has everybody seen laptop RAM before?
I have one on my keychain.
What's that?
I have one on my keychain.
On your keychain?
Yeah.
That's why you do all the labels. So there. Here's the processor you can pass around.
Oh, no, no problem.
Let me grab some.
That's literally supposed to be.
I thought it out before. So here is a SODIMM. It is 8 gigs. Yeah. And it's DDR4. I shouldn't have that. Usually don't. So this is what a
Yeah. It's like
this is a SODIMM. This is what the laptop looks like. This is the retro warranty. So there's another type of memory that we use that is not necessarily, it doesn't necessarily come in sticks itself, and that is our cache. So there is L1, L2, and sometimes L3 cache. And this is a temporary memory that is actually saved in, or it's actually part of the CPU itself, okay? So this is like right before it dives in there, right before it goes into the chipper. If you've ever looked at a chipper, you know how it has like a little funnel right there? That is like the final resting place before anything goes in. That would be the same as our cache, okay? So the cache is actually on the CPU itself, so it's important when you're pricing out different CPUs to check your sizes of your cache as well. L3, I don't really, again, it's more higher end workstations and servers, so you might not run into that. You might, the way that the CPU technology is going, that line between like a server CPU and a desktop CPU that line is very blurred right now. in that you're getting a lot of performance out of these high-end servers. So, I'm sorry, these high-end workstations. So, I think we're just going to see more and more of that kind of coming into one line, one product line. So, memory modules, let me pause that. So, one thing that hasn't really made its way into PCs or workstation builds is this idea of error checking, or ECC and non-ECC. Okay, so you would think that you would want, like when you send information from your RAM into your CPU, you would think that you'd want to error check that and make sure that it's the right thing, right? Okay, so that costs a lot of money to do that and a lot of resources to do that. So why don't you think we do that on workstations?
Does it slow it down?
Because it would slow it down, and what you're doing is not really mission critical, okay? So, like we watch Die Hard, so the systems that are running those systems, those are important. Like we want to make sure that we are doing checking to make sure that there is no errors on the memory, and to be able to alert on those things so those fire sale like things don't happen, okay? That's a little bit of a life and death situation. Whether or not there will be like 1 pixel off on the video game that you're playing, probably not important and probably not worth you paying more money for it, but also more resources for it to do that. Okay? If it's important to you, then build away. I will not stop you from doing that, nor will the people that take your money. Okay, they will absolutely take your money. So it's important that you know kind of what ECC is and what it's aligned to. You don't have to take, again, a deep dive into it, but you have. If you see that, I just want you to think has to do with servers. ECC equals servers. Okay? I'll say it together. ECC equals server. Okay, it's supposed to be all together. You guys suck at this game. Talk about a couple different adapter cards. Again, this is, like I said, this is longer than I would ever lecture. I usually cut it off at 30 minutes, but we have a lot of catching up to do. So these are different expansion cards. So you can see here we have our sound cards. eSATA you won't see as much anymore. eSATA was kind of pre-USB-C, and it was a way for us to get those SATA speeds on the outside of the computer, like on our external devices, and not be bogged down by our USB bus. But now that has kind of not the case anymore. Like we're using the faster buses in order for our I/O, so you don't really see eSATA anymore. But what it did was it plugged in, and you did get more SATA connectors on some of the cards, but then it gave you 2 external ports that you could plug in your eSATA drives to. But that was pretty short-lived. I'm someone that buys a lot of technology, all the latest stuff, and I never once in my life had a eSATA drive, so it was around for a very, very short time. A couple other things you might see, obviously your video card, your wireless NIC if it's not built into your motherboard. You might upgrade your sound card if you want. If you want better audio quality or more, like let's say you wanted a view surround sound and it's not built into the board, that's where you would do these different adapter cards. You can also put a TV tuner card in there, but anymore with the way streaming's become, you don't even do that. I remember when I was building, I wanted a TV tuner card so bad that I could like set up Windows Media Center, which was like a home media thing that used to be built into Windows that you could get, and like have your DVR interface, and that was like the cat's meow. Now it's like, let me open up YouTube streaming app. Cool. Okay, now watching TV. They come in, the actual cards themselves, or those ports, come in a lot of different flavors based on the different speeds that you need. So again, if you look at our boards, you can see we have our graphics, we have our standard PCI, and then we have our X16 slots. So again, these ones with our clips, those are going to be for our actual video card itself, whereas these ones are just based for just regular adapter cards, and then screwing them into the case is what kind of secures them in place. These little locks that are on the end help it because video cards tend to be heavier, especially the latest edition. You have to put like little, like almost like pillars on them to keep them supported just because they are so heavy. And then back in the day, we also used to have AGP ports, which were the advanced graphic ports. That is what we used to use for our video cards. Again, one common thing that you're seeing on the A Plus is me saying, we used to, we did that. It's not like that anymore. That is still the A Plus test. Okay, so the A Plus test wants you to have this deep knowledge because when you walk into an environment, it is not all the newest, latest, and greatest. We are very fortunate here at the Career Center that we have really good technology, in my opinion. Like we have wireless, we have Chromebooks, we have PCs, we have interactive TVs. Like we have a lot of good technology here. That's not the case in most places that you have, especially if it's like a small business. One of the clients that I do consulting for, you would be shocked if you were to walk into this place because there's a lot of Windows XP still there. There is a lot of Windows 7. They have like no backups. They have really old servers. But again, that's kind of the norm. So if something breaks, you're still going to be required to fix it. So you're going to have to know how to troubleshoot all these different things, or at least have knowledge of it to know what to Google. Like it's fine that you're just going to Google things, but you have to identify. You know, if you have an adapter card that's plugged into this slot, you're going to have to know what kind of slot this is, so you know what to Google. You know, IT is a whole lot of Googling. I'm not going to lie and say it's not, but you have to know. You have to know what you're looking for. You have to tell Google what it is that you want to pull out of the information that you need. So when it comes to storage devices, you have a couple different options. You have your slow spinning disks. You have your solid state drives that go through the SATA connections. Then you also have your faster, which is your M2 drives. Okay, so that's going to be the M2s are directly connected to the board. There's no slowdown in any like throughput and stuff like that. It is directly connected. So the M2 is going to be your fastest, with your traditional hard drive being the slowest. So, question to you. With this technology, why do they still sell those slow drives? They're cheap, okay? So even if they're not fast, they're still cheap. They can hold a lot of data, right? Yep.
They've been tested with time and they've worked for forever.
Exactly. So it's a time-tested technology that we know works because we've been fine-tuning it and making it better and better over the years, right? So again, this is something that when you are doing your risk assessments, you're looking at adopting different technology, you can say, hey, we know what the half-life is on, say, a hard disk drive, whereas the M2s are kind of new, so we would only want to put, you know, kind of temporary stuff and not like archival level quality stuff, okay? We used to use the technology known as PATA, which is parallel ATA. Again, this is just for A+ knowledge. You should not run into this anywhere. But just for a kind of a point of reference, look at what our speeds were, okay? So back in the day, we were doing 8.3 megabits per second, okay? Yes, you read that, megabits per second. And then we figured out EIDE, our blue cables, and we got 16.6 megabits per second. And like, we thought that was great. Like, it was more than we had ever had. And then SATA first came out, and we're like, holy crap. And then like RAIDs came out where you had like 2 drives, and you could do RAID 0 and put some data here, some data here, and it made it faster because they could access it faster. And now we're kind of spoiled by 6, 8 gigabits per second with the latest serial connection speeds. So just be aware that the legacy, which is going to be a wide gray ribbon cable, that is known as IDE or parallel ATA. Okay, so again, it shouldn't be on the test. It's more of a reference to show you kind of where we were and then kind of where we are now. So this one on the bottom, tape drives. I do want to talk about tape drives really quick. Do you think tape drives are still used today?
Yes, they are.
Yes, they 100% are. What's that? Sadly. So, like we mentioned earlier, tape drives have been tried and tested over and over again, and they have a really, really long half-life. And what I mean by half-life is they have a really long lifespan, meaning they will be around a long time. And a lot of times, you use tape drives for archival purposes, meaning like we have to, I don't know if you guys know this or not, but if there is a student record, so if I email another teacher and it has your grade in it, that has to be retained for a very long time. Even though it's just an email, that specific email has to be held on to. It's the same if we talk about like medical records, for example. They have to be retained for a very long time. So, does it make sense for a business or institution to put that on an M2 drive or a solid state drive? No, because it's what's called glacial storage, which means it moves about as fast as a glacier, right? We might need to get that in 50 years. We might need to go back and grab that one piece of data, okay? So for that, that's why we use our tape drives. And tape drives on the actual units themselves are, a lot of times they'll have two places where you can put the tapes in and take the tapes out. It used to be a guy that I knew, he used to work for me. He actually went to a job in Columbus, and this was within the last 6 or 7 years, and his whole job was just rotating tapes. So when a tape got full, take it, put a new one in, and he'd sit back down. And then one would pop, he would go, he'd take it out, put a new one in, and you have to label it and stuff. But then they have actually like built like automated like tape things too, because you rotate your tapes through to make sure that, again, the most important thing to any backup is recovery, right? It's great that you can back up your stuff, but if you can't recover it, what's the point? So you have to go through and just test, the data that's on there and make sure that it was good data that was being backed up. You guys know traditional hard drives, blah, 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 blah. Semiconductor storage, so that's our solid state drives as well as our M2s. Any questions about any of those? I feel like you guys have probably grown up with these, so you know them a little better. Just a smaller, semiconductor storage is more, instead of it being like a spinning disk like a record, it is directly addressed storage like an SD card, for example. Your SD card or your memory card for your camera was one of your first kind of solid state drives, and then they've thus been modified to be used for computers themselves. Cool. NVMe, we talked about that. Yeah, the hybrid drives were there good for a minute. Apple actually came out with them, I forget what they called them. Fusion drives is what they called them. So it's in between a hard drive, like a magnetic hard drive, and a solid state drive. So they are faster, a little bit faster, but they were a pain, like they were very short-lived. I'm trying to think if there's anything else. Your self-explanatory stuff. Optical drives, we know what optical drives are. We have CD and DVD drives or Blu-ray disc drives. The difference between them is just the storage that's on them, and it's a different laser that can write data at different depths and densities. We used to be able to, like, our temporary disk storage was like 4 gigs, and that's all we had. Now Blu-ray are up to 30, but you don't really see those driving around anymore. If you are studying for your A+, I would make sure you know this chart. You should know that CD-ROMs were 700 megabytes. You should know that DVDs were 4.7 unless they were in a dual layer, and you would just double that number. And then Blu-rays start at 25 gigs. You definitely are going to have to know that for not only a test in here, but for your A+. Video ports and cables, it's important to know these as well. So we have our DVI, which is our digital visual interface. This kind of took over from VGA. So VGA was the cables that we used, and they are still in use today. These computers are using DisplayPort, but a lot of them are still using just your standard VGA connection. And honestly, for most end users, they're not going to notice the difference between the higher resolutions that you can get from a DVI or a DisplayPort cable. This is another A+ kind of matching question that you'll see. They'll have these ports up there, and you'll need to be able to point them out. The most difficult one is HDMI versus DisplayPort. They look very similar, except DisplayPort has, instead of HDMI where it comes out like almost like wings, it only has one wing. So let me actually, I'll draw it up on the board real quick. So your HDMI port that you're used to seeing comes down like this, comes up. Like for your HDMI, your DVI is just going to look like that, where it's just like cut off on one side. So if you do some digging into HDMI, and you'll ask yourself, well, like why do computers have DisplayPort or a bunch of DisplayPort but only one HDMI? Look into licensing of HDMI interfaces. Every time they are used, money has to be paid because it is a protected format between basically a bunch of companies came together. And you see this a lot in electronics. They all came together to build a standard, and then every time you use their standard, you have to pay for it. So then other standards will come along that are more open that you don't have to pay for. So it's interesting. A lot of people don't realize, like even like USB, for example, is similar as well. So if you want an interesting read, just look up HDMI royalties and all the different companies that were part of that. So another thing that you're going to have to know for the test is these kind of old school systems. And I will tell you from experience. So let's say you have a dead computer and it has these ports. I have like a USB keyboard and mouse plugged in. A lot of times it won't work unless you have these. So I've always kept around a PS2 mouse and keyboard just in case I need to get into those devices or I have to utilize those green and purples. But that is what was used back in the day for our keyboard and our mice. Another legacy technology is the game port. We don't really see that anymore. It's like a wider serial connection. Here's the IDE cables that I was telling you about. They're wide ribbon cables that have since been replaced by SATA as well as USB on the outside. There are converters. You guys have probably seen these before. As a Mac user, unfortunately, we have to like dongle everything because Steve Jobs didn't like buttons and didn't like ports. So we have to carry dongles everywhere. So when I say dongle, a dongle is something that takes one port and will either give you a bunch of different ports or more of the same port. Is my white one laying out here somewhere? Thought I had it. I was just using it. I have more in my bag, but your dongles will take like your USB-C port, and it might give you another USB-C port, HDMI, and USB. So you take that one port that you have, and now you get 3 or 4. And as I've been watching kind of the PC, like the builds and like the laptop builds, that's becoming more and more of the standard where there's just going to be your plain Jane USB-C ports on there, and then you're going to have to use different dongles to get the ports that you actually need. So you can see here, we're taking one USB-C port, and we are giving you a USB 3, an HDMI, as well as a USB-C, which you should use for power if it's your only one. So yeah, USB-C is great, and you can do a lot with it, but you are limited to that I/O bus. So cramming like a bunch of stuff on there, you could cause, if you keep like data chaining, you could cause issues. That highway could fill up. So it's based on the actual standards itself and also speeds and what can go across the, what can actually go across the pipe, if you will. So Thunderbolt is a technology that was used, it was first used by Apple throughout all of their, throughout their entire product line to be able to do video over the connection as well as power, all these different things they could do it over a single bus. and now it's kind of morphed into the USB-C standard. But again, it's based on what can actually go in and out of the ports, and also the resolution, like for video. The higher the Thunderbolt number, the more video throughput that I've noticed that it has as well, because it's just getting better over time. But there for a while you only saw it in Mac, and now it's been slowly trickling over into PC as well. But the only difference is really the type of data and the speed in which it can go across that same connector. Stuff that you need to know for the A Plus as well. Flatbed scanner. Again, this is older technology, but it had a piece of glass that you could then close the lid on, and it would scan like pictures and stuff like that. We have our KVM switch. Anybody know what a KVM switch is? Or what it stands for? Yeah?
Does it switch a bunch of peripherals so you can use different sets of keyboards and mice for the same set of keyboard and mice for different computers?
Absolutely. So in my rack at home, I have a KVM for, mine's an 8-port rack-mounted KVM for the different servers that I have in my rack at home, and I can press a button and it'll switch my single keyboard and mouse that I have, it'll put it into that PC, and then it'll switch my video input as well. So let's say sitting here you had a Linux machine and your PC, you could have a button that you could press and switch between them and use the same keyboard and mouse as well as the same monitor. They also have IP connected KVMs, which would allow you to do that same thing but via a web browser, and then you could have access to everything as well. But yes, it allows you to control multiple devices, and they are great to have in a server rack. Otherwise, you have to like get behind and like switch your ports out or access it remotely. So some newer technology, I guess you would say, as far as our inputs would be touchscreen, just like your phones. You guys know how that works with all the different touch gestures and whatnot. You also have a stylus. You don't really see stylus as much anymore, but again, you might work for the company that supports the POS terminals at TSC or Walmart, so you're going to have to directly interface with like styluses and stuff like that. But that's the little pen that's on the screen that allows you to like write on the screen. Or if it's like a graphics shop, a lot of them will use tablets in order to do like drawing and any artwork. Magnetic strip reader, that's your credit card reader. Sometimes you'll see those for like door entry, but they're not really used as much anymore. Barcode scanning, which we used when I was creating your accounts, it just takes those lines and it makes it so the computer can read it. A lot of people don't realize it, but that is just a font. So you can go and download a barcode font, and you can print off your own barcodes, and you're going to be able to scan them. So you could literally make them whatever you want them to be. So like, for example, for me and Magic Cards, I can put a barcode on a box and make it so if I scan it, I know every card in that box, just by typing in, having it set to use that code, just to look up in a database and see all the cards that are in there. So you can put whatever you want in barcodes. You don't have to have any special software or anything like that. You guys should know all those. Again, this is all older stuff. Facial recognition, this is kind of newer. NFC, so like you guys just saw where you can now accept credit cards with your phone without having any other dongles. Okay, so as like a merchant, I can. So if you walked up with your card, you can just tap it on my phone, and it'll actually process it, not like person to person, but actual person to business. So that technology has really taken off in the recent years. Same thing with like biometrics. So biometrics are going to be anything that is you physically. So your fingerprint, your retina, your voice recognition, those are all going to fall under those biometric devices. And we'll get into those a lot more when we get into more of our security studies. So those are all input devices because we're putting data into our computer. Now let's talk a little bit about output devices. Output is going to be anything that you can see or hear. Okay, so, or like for example, a printer, you would still see it, but it's something physical. So those are going to be more of your output devices. Monitors come in a couple different things, or a couple different standards, if you will. Things you need to know. LCD stands for liquid crystal display. LED stands for light emitting diode, which is the lights are actually coming out of the screen itself or from the diode, and then it's hitting that front panel of the actual display. And then you have OLED. And the biggest difference between LED and OLED is, that I've noticed, is the contrast that you get with organic LED. The blacks just tend to be a little bit darker. DLP is an older technology. Again, it's just good to know what it stands for. In this case, it is digital light processing. You see this a lot on projectors as well. If it's a DLP projector, it tends to be a much brighter, a better, like almost like home theater quality. Back in the day, all the home theater projectors were DLP. Do you guys know the difference between AR and VR? Feeling good about that? We might play with this on Friday. We might do some VR stuff. We're taking the test over module 1 on Friday also. So the plan is for you guys to come in, do the, we're going to do our Kahoots, do the test, and then just chill out with some VR. And I think I have my wife talked into the Mario Kart augmented reality thing. That was pretty fun, so I might bring that in as well. The difference is VR, you put the headset on and you are in a virtual reality. So you are in like Beat Saber or Fruit Ninja, you're in like a totally different world. Whereas augmented reality is you take the reality that we are currently in and you augment it by adding things to it. So if you've ever played Pokemon Go and it's regular, the way it was designed, you would literally be looking around for Pokemon and then they pop up. That is augmented reality. They are augmenting the reality that you are currently in. Make sense? So some actual applications of that, for both of those really, at least in my kind of realm, is for training for like military ops. We did have a program going in the Army. It was actually just canceled because soldiers were getting sick. So we'll see if that one comes back. But we had, I think it was Microsoft HoloLens technology, where they could actually load like an entire mission into the VR goggles, and the weapons were also tied into the whole like system, and they could practice ops before going over, so that way when like a Bin Laden attack happens, like they know the building like the back of their hand because they've actually literally been in it, and as they're stepping through it, it's changing. It's not like like you've seen on movies where we have just like a bunch of wooden walls that we used our intel in order to try to think maybe this is how it is. We're actually going to use real imagery to try different scenarios before they go over there. So augmented reality too. So augmented reality would be kind of the same idea with the soldier's goggles that's actively scanning. So if there is like say a known person, it might pop where it like shows up above them what their name is. There's technology like this in large crowded areas. So like in like NFL stadiums and stuff like that, where they can casinos too, where they can actually monitor people coming in and then ping them based on if they're in a database of some sort. And some schools are even doing this as well for like sexual predators and stuff. So if a sexual predator walks in the building, they'll instantly be alerted. And then they'll actually be like, if you look at the screen, you'll see like a red dot as they're like walking the hallway, so that way you know exactly where they are. So they're kind of augmenting that reality. Printers, we talked about printers already. Boom, okay. So last thing we have to talk about is computer disassembly, but you guys are gonna do that in person tomorrow. So as soon as you get in here tomorrow, I want you to grab one of the PCs and you'll grab a note card and put your name on it and find some space. I'm gonna hopefully have my seniors kind of clean off these workbenches, clean off some more space for you guys, and we're gonna go through kind of the disassembly of a computer, and then in the next lab, it is kind of putting it all back together. So, chapter summary. Woo! That was a lot. Again, that was twice as much as I normally lecture, guys. So don't think that that's how it's always going to be. That was a ton of review stuff that a lot of you guys already knew. So I just wanted to push us through it. I know it's a ton of like fire hose type of information. But does anybody have questions over anything that we learned?